Welcome to Jhunnik channel. Welcome po kayo guys sa aking YouTube channel. Ang channel pong ito ay nakapagbibigay ng dagdag kaalaman sa ating lahat. I am very thankful to my beloved subscribers and to all supported viewers in my videos. Thank you so much. If you are not willing to learn, no one can help you. If you are determined to learn, no one can stop you. Kaya, kung hindi ka pa nakapag-subscribe mga ka-viewers sa aking channel, just click subscribe and click the bell. Hello po, magandang araw. Dagdag kaalaman na po to. Our topic for today is all about proteins and 3D structure of proteins. Proteins are essential nutrients for the human body. They are one of the building blocks of the body tissue and can also serve as a fuel source. As a fuel, proteins provide as much energy density as carbohydrates. For calories per gram, and contrast, lipids provide 9 calories per gram. Protein is a macronutrient that is essential to building muscle mass that is commonly found in animal products, though is also present in other sources such as nuts and legumes. Proteins is composed of amino acids, which are organic compounds made of carbon, hydrogen, nitrogen, oxygen, or sulfur. Amino acids are the building blocks of proteins, and proteins are the building blocks of muscle. Examples: the meat, seafoods, greens, beans, dairy are good sources of protein. How much protein? Most people need 20 to 30 grams of protein per meal. It recommends that 10 to 35% of daily calories come from protein. The amount of protein foods a person should eat depends on age, sex, and level of physical activity. A safe level of protein ranges from 0.8 grams of protein per kilogram of the body weight. Protein: all food made from meat, poultry, seafood, beans and peas, eggs, processed soy products, nuts, and seeds are considered part of the protein group. 3 types of protein. First, the complete proteins. These foods contain all the essential amino acids. They mostly occur in animal foods such as meat, dairy, and eggs. The second, incomplete proteins. These foods contain at least one essential amino acid. So there is a lack of balance in the proteins. Plant foods such as peas, beans, and greens mostly contain incomplete protein. Complementary proteins. These refer to or more foods containing incomplete proteins that people can combine to supply complete protein. Examples include rice and beans or bread with peanut butter. The 3D structure of proteins. Types of protein structure. First, the primary structure, and secondary structure, tertiary structure, and quaternary structure. So, the primary structure describes the unique order in which amino acids are linked together to form a protein. Proteins are constructed from a set of 20 amino acids. Generally, amino acids have the following structural properties. A carbon or the alpha carbon bonded to the four groups below. A hydrogen atom and a carboxyl group or COOH, an amino group or NH2, a variable group or R group. All amino acids have the alpha carbon bonded to the hydrogen atom, carboxyl group, and amino group. The R group varies among amino acids and determines the differences between these protein monomers. The amino acid sequence of the protein is determined by the information found in the cellular genetic code. The order of amino acids in the polypeptide chain is unique and specific to a particular protein. Altering a single amino acid causes a gene mutation, which most often results in non-functioning protein. Next, the secondary structure refers to the coiling or folding of a polypeptide chain that gives the protein its 3D shape. There are two types of secondary structures observed in proteins. One type is the alpha helix structure. This structure resembles a coiled spring and is secured by hydrogen bonding in the polypeptide chain. The second type of secondary structure in proteins is the beta-plated sheet. This structure appears to be folded or plated and is held together by hydrogen bonding between polypeptide units of the folded chain that lie adjacent to one another. Tertiary structure refers to the comprehensive 3D structure of the polypeptide chain of a protein. There are several types of bonds and forces that hold a protein in its tertiary structure. So, hydrophobic interactions greatly contribute to folding and shaping of protein. The R group of the amino acid is either hydrophobic or hydrophilic. The amino acids with hydrophilic R groups will seek contact with their aqueous environment, while amino acids with hydrophobic R groups will seek to avoid water and position themselves toward the center of the protein. Hydrogen bonding and the polypeptide chain and between amino acid and R groups helps to stabilize protein structure by holding the protein in the shape established by the hydrophobic interactions. Due to protein folding, ionic bonding can occur between the positively and negatively charged R groups that come in close contact with one another. Quaternary structure refers to the structure of protein macromolecule formed by interactions between multiple polypeptide chains. Each polypeptide chain is referred to as a subunit. Proteins with quaternary structure may consist of more than one of the same type of protein subunit. They may also be composed of different subunits. Hemoglobin is an example of a protein with quaternary structure. Hemoglobin, found in the blood, is an iron-containing protein that binds oxygen molecules. It contains 4 subunits, 2 alpha subunits, and 2 beta subunits.